this time we are going through as teachers, as students, as parents, as the international world all over, will come to an end. Last time, that was Monday, we were looking at the cumulative distribution function. We worked through several examples, and I left you a few numbers. I will work through one number basically to confirm to those that worked through it. I will not go through the details, but I will give you the function, and then we shall progress to today's work. We had one of the numbers given as f of x being equal to x out of 4 with a range of 1 to 3 and 0 elsewhere. And you were asked to find the cumulative distribution function and also sketch. Like I have said, I will not work through, but I will give you what I expect you to have got. The solution for the cumulative distribution function should have been 0 with x less than 1 and x squared minus 1 over 8 with, of course, 1 less than x less than 3, and then you were expected to get, of course, 1 elsewhere. No, 1 with x greater or equal to 3. This is supposed to have been the answer for that. Now the sketch that you expected to get from this one should have given you, of course, x, f of x. You start with a table and you put in these values of 1. You put in a value in between 1 and 3, say 2. And after putting in 1, when you put in 1 here, you have 1 minus 1, which would give you a 0. And when you put in 2, you will get 4 minus 1, which will give you 3 out of 8. When you put in 3, you'll get 9 minus 1, which will give you a 1. If you are plotting a cumulative distribution function, note that when you substitute in the upper limit, you must be able to get 1 there. And of course, when it comes to the sketch, we have our x here. We have our f of x. We have our 1, 0. If this is 1, that point would be here. We have our 2, 3 out of 8, assuming that that 2 is there. The 3 out of 8, if I put it here, that point would be right over here. And then when we have our 3, that would give us a maximum, which is 1. So it would give us a point around here. Given that the highest power of x is squared, it would imply that you'd get a curve, and therefore you would join with a freehand to get the curve as that. And of course, this would be the f of x is equal to 1 here, and then you would have f of x over here being equal to x squared minus 1 out of 8. That is the sketch I expected you to get for that number. Today, I intend to wind up this topic. We have been here for quite some time, and hopefully we should be able to go through. So those who tried out this number, you can confirm there are steps that you took to arrive at this. We said when you fit in the minimum value for f of x less than the lower limit of the interval, it should be able to give you 0. And then for f of x for x tending to t, then you would have the t over 4, which you'd integrate between 1 and 3. And when you get the integral and you fit in the limit as x from 1 to x, you should be able to get this function. And when you feed in 3, as we have done, it gives you the final function here, which we indicate as the maximum. So these 3 strips must be indicated. 1 for the less than the lower limit, the actual function for the actual limit, and then the maximum, which is 1 for the x assumed to be greater than the upper limit there. Hope that is cross-checked. On the last number that we ended with, we do not have enough time to work through the last part, but I showed you the answers, and I expect that when you substituted in for f as was given, f 2.5 and f negative a half, you were able to get the answer given. Today I want us to note that if we are given a cumulative distribution function, we can actually be asked to find a PDF function. We are getting the cumulative from the PDF, but we can be given a question where we are given a cumulative distribution function and they want us to find a PDF. So we shall look at that. I have put, how do we find that? Let us look at one quick example of how we can find that. That if the cumulative distribution function f of x is given by 0 x cubed over 27 and of course 1, and the limits that x is less or equal to 0, 0 is less or equal to x less or equal to 3, and of course this one is x greater than 3, then they are telling us if you are given that, find the PDF. Find the PDF f of x. Find the PDF f of x. This is a simple approach that requires you to note that f of x, which they want, is supposed to be given by d by dx of the cumulative function f of x, which we can also write as f of x prime. We simply differentiate the given expression and maintain the same limit. And therefore, we can say that since our cumulative distribution function is given majorly as x cubed out of 27, our f of x is going to be d by dx of x cubed out of 27. We differentiate this, and differentiation is multiplied by the power and then reduce the power by 1. So we shall get 3x to the power 3 minus 1 over 27, implying that our f of x is going to give us x squared out of 9. And we can conclude and say, hence, our f of x will be given by x squared out of 9 with a range of 0 less than x less than 3 and 0 elsewhere. Just as simple as that. just as simple as that. We will have our f of x, which we call the PDF. So we can simply say that the gradient of the cumulative distribution function gives the probability density function. We can take it as a knot. Gives the probability density function, which we are calling small f of x. Simply differentiate. Even if it was a function with two strips or two different functions, you differentiate each function, and whatever you obtain will be the PDF of the required function. I want to assume that this is very clear, and you have got that very well. I will therefore be able to give several questions, hopefully at the end of this lesson. Right now, I want us to look at one more example, and then we can look at the next and the last part of our discussion for this topic. You can be given a cumulative distribution function like this one. We are given that x is a random variable. X is a random variable whose cumulative distribution function is given as f of x being equal to lambda, the sine of x, and 1, with the range given as pi out of 2, and of course 1 with x greater or equal to pi out of 2. They want us to find the value of k, which is the constant, and they also want us to find the probability that x is greater than pi over 6, given that x is less than pi over 2. And they want us to find this to 4 dp's. They want us to find that to 4 dp's. You are given a PDF as indicated, and they want us to find the value of the constant. Find the value of the constant. Find the value of the constant. The approach is very simple. Remember, when we are looking for the cumulative function f of x, the first step is we feed in a value that x is less than the lower limit. And the last step is that f of the upper limit should be able to give you 1, which we call f of infinity. So if we consider the solution, we shall say that since f to infinity is equal to 1, then f to infinity will mean that the function f of x is equal to 1 when x in this case is the upper limit, when x is equal to pi by 2. So f of pi by 2 is going to be considered to be equal to 1. But our f is known. Our f of x is lambda, the sign of x, which will imply that lambda times the sign of pi by 2 is equal to 1. You either use radians, or if you are aware that pi is 180 degrees, then you can say that the sign of pi by 2 is the same as the sign of 90, which is 1. And this implies that lambda times 1 is equal to 1, of course implying that lambda is equal to 1. And therefore, it is important that you restate the function and put in the value of x. Once you get the constant, it is always important to restate the function or to rewrite the function given. But the question was asking us to find the constant. Part 2, they want us to find the probability that x is greater than pi by 6, given that x is less than pi by 2. I expect that you're capturing this. We can have a few minutes for you to finish capturing that before we look at this second part. Before we look at the second part, simply consider f to the upper limit as equivalent to 1 and substitute in the upper limit in the function equate to 1 and solve. If you are using a calculator, you can use radians. The sign of pi by 2 will definitely give you 1, or convert it to degrees, which will give you 90, and the sign of 90 degrees is equivalent to 1, and proceed to look for that constant. To find this, I will start from here. We have not looked at conditional probability, but remember that P of A given B is the same as P of A intersection B over the P of B. This is the concept we are using here. It's the concept we are using. So if I use that concept, it implies that P of x greater than pi by 6, given that x is less than pi by 2, if I use this, it implies that it is equal to the probability of A, which is pi by 6 intersection pi by 2 over the probability of pi by 2. Okay, I need to bring in the x. P pi by 6 less than x intersection x less than pi by 2. So this implies that we are looking at the probability of pi by 6 less than x less than pi by 2 over the probability of pi by 2. And from what we saw last time, we simply now need to look at this, but P pi by x, pi by 6 less than x means that x is greater than pi by 6, is basically f of pi by 6. And P of x less than pi by 6 means that x less than pi by 6 by 2 is also the same as f of pi by 2. So if I look at this right away, I'll simply say, if I took it straight away, it means that A will give me P or f, the cumulative function of f pi by 6 minus f pi by 2 over f pi by 2. I will use the cumulative functions, and when we use that, remember our lambda was 1, so I will get, upon substitution, I will get the required value as the sine of pi by 6 minus the sine of pi by 2 over the sine of pi by 2. And therefore, if we take the given expression P of x greater than pi by 6 given x less than pi by 2, which they want, from our calculators, when you compute, you should be able to get using your calculator, the sine of, it should be the sine of the upper limit it should be able to give us the upper limit, which is pi by 2 minus pi by 6. This should be 2, this should be 6. And when we use our calculators, the sine of pi by 2 we have already seen is 1. So we shall get 1 minus pi by 6 is the same as 30 degrees. The sine of 30 is a half. And again here, we have over 1. So this implies that our answer is a half over 1, which will give us a half. Which will give us a half. There was an adjustment from the original question, but we will leave the solution as that. That therefore, our probability that x is greater than pi by 6 given x less than pi by 2 will give us 0.5. They had said 4 decimal places, so we can put these zeros to 4 dp's. It gives us 0.5. It gives us 0.5. You can capture that. You can capture that. And I'll put part C for you to try out. With the same number, try out just using f of x as 1 as the sine of x from the same range of pi 0, 0, 0 less than x less than pi by 2 and x greater than pi by 2. Let us take that. Find P of x greater than pi by 6 given x less than pi by 3. I want you to try out this in your free time. Try out that. It's the same number, but I've changed something slight. I've changed something slight and give your answer to 4 dPs. Give your answer to 4 decimal places. I will rub for this part. And introduce I'll introduce the last part of this topic, which I'll call uniform. Sometimes referred to as rectangular. Distribution. Uniform distribution. Probably this is the simplest part of this area. We are saying that this is a continuous variable, random variable, that has a PDF that has a probability density function where we define that function f of x as the function of 1 over b minus a for a less than x less than b and 0 elsewhere. It is the function where our PDF is given by that. And this implies that a and b are constants. They are constants with a or is less than b. They are constants with a or is less than b. And when we sketch this function, it gives us, I'll put this simple sketch here, that this is f of x and this is x. If x is given as a and b here, this function ends into what we call a rectangle. And the function is ideally here, where we say our f of x is actually equal to 1 over b minus a. The reason why it derives its name as rectangular, because the shape formed is rectangular. And this is 1 over b minus a. This value here is 1 over b minus a. And it derives its name from the shape. We can say it derives its name from the shape it forms. It derives its name from the shape it forms. We can also say that if the variable x is rectangular, then we can write can write this function as x is approximately rectangular into a, b. We can say x is approximately rectangular or is a function that is rectangular and is written in that form. Basically, that is the rectangular function. And we can look at one simple example. Number one, they can say, write down a PDF of a random variable x which is uniformly distributed over the interval and they give us a. We can say the first interval is 3 to 5. B, we can say 4 to 7. If you are given this, and you already know that this is the general expression, it is very easy for you to write that function. If they say 3 to 5, what does that mean in terms of inequalities? From 3 to 5 inclusive. What is the value of A? What is the value of B? If this is the function, we write the highest limit minus the lowest limit. So it implies that our function is our solution for the first part is the function f of x is going to be equal to 1 over the 5 minus 3 with the limit. The limit is the same, 3 less or equal to x less or equal to 5. Because it starts from 3 to 5, so they are inclusive, 0 elsewhere. That is part A. Part B, similarly, our f of x will be given by an expression that we can write as 1 over 7 minus 4, 4 less or equal to x less or equal to 7, 0 elsewhere. It is allowed for a candidate to go ahead and say it's 1 out of 2 or it's 1 out of 3. It is allowed for a candidate to go ahead and say that. Even if we had C, for example, say from P to 5, the f of x will be a function from 1 over 5 minus P. From P less or equal to x less or equal to 5, 0 elsewhere. Zero elsewhere. I hope that is very easy for someone to do. That is the first example under the rectangular distribution function. The general expression is this, which basically guides or requires you to simply substitute in B minus A. I want to put another example that goes a notch higher than that right over here. I want to put another example as you finalize copying that. They can give us a question, and they say, I have told you that a random variable x is approximately rectangular with values now as 6 and 9. And they're telling us to find using that function, find the probability that 7.2 is less than x less than 8.4. That is part 1. Find the probability that that is true. They can also ask us to find the expectation of the random variable. They can also ask us to find the variance of the random variable. So I'll look at this solution, and then I will talk about how do we find the variance of this function. So in our solution, we must first generate the function. Since our range is 6, 9, it implies that our f of x is going to be 1 out of 9 minus 6, 0 elsewhere, and 6 less than x less than 9. So if they want us to find this probability, it means that they are telling us to find p 7.2 less than x less than 8.4, given that it is a rectangular function, will be simply obtained by getting the probability of the same range. The probability of the same range using the integral. Probability will be the same as the integral from 7.2 to 8.4 of this function, which you can write as 1 out of 3 dx. The lower limit is 7.2, the upper limit is 8.4, and the function is that. So we simply integrate, and then we fit in our values and use our calculators to get the answer. P 7.2 less than x less than 8.4 is going to be equivalent to x out of 3. We put in our limits, 7.2, 8.4. That means that it is a third into 8.4 minus 7.2. When you subtract this, definitely you'll get a third times. This will give us a 2, 4 minus 2, and a 1. And this will definitely give us 0.4. So we can conclude and say that the probability that 7.2 is less than x less than 8.4 will give us 0.4. It will give us 0.4. The next part requires us to find the expectation. I'll simply generate the general expression that expectation x, just like initially we saw, is the integral of x f of x dx from the limits given, say a to b. Find the expectation of x. It implies the general expression, therefore, assuming I'm taking this as the general function, our ex is given by x over b minus a over b minus a. If it is x, f of x, it is x over b minus a dx. because if we have this as the expression, we are integrating. We are integrating that between the upper limit and the lower limit. And if it's a general expression, I can say from infinity to a point. And if we integrate this, if we integrate x, we shall get x squared over 2. So the expectation, I'm assuming that this is way long captured. Will be x squared over 2 into b minus a. The expectation, the general expression would be that. And if the limits are known as ab, it means we are saying a squared, no, b squared minus a squared over 2 into b minus a is the expectation, the general expression. So the expectation, general expression, will be the same as mathematically, I believe all of you following can see that we have a difference of 2 squares. So we shall have a, we shall have b minus a into b plus a over 2 into b minus a, and this will cancel with that. So the general expectation of x is actually b plus a over 2. This is the general formula. And therefore, I can say e of x, if our function is this, is going to be the same as 6 plus 9 over 2, which will give us 7.5. I have derived the general expression for the expectation, and I have gone ahead to answer this one. I am doing two things at the same time because we need to know the expression for expectation. Now, to look for the variance, I will still derive the expression for the variance. Part 3, variance of x will be given by x squared f of x dx, the integral, in this case from a to b again. So if we repeat the same variance expression, the general one will be x squared over b minus a, that is the f of x, dx, and we are supposed to integrate from a to b. This will give us x cubed over 3 into b minus a, and our limits are a, b. So we shall have b minus a cubed over 3. This is our variance expression. Will be b minus a cubed over 3 into b minus a. If we simplify this, it's the same as b minus a into b minus a squared over 3 into b minus a. Because this is cubed, one is squared and the other one is not. Sorry. This is, they are not, it is b cubed minus a cubed. B cubed minus a cubed, which we don't write like this. B cubed minus a cubed over that. Now, this can be simplified. The variance of x we are saying is b cubed minus a cubed over 3 into b minus a. This numerator can be simplified, but we can leave it over there, and therefore get the variance of x for this function as 9 cubed minus 6 cubed over 3 into 9 minus 6. And this will give us the variance if we substitute and compute, we would get the denominator as 9, and 9 cubed is the same as, I think, 729 minus 6 cubed, that is 216. When you simplify that, you'll get 3, that is 3, you get 1, and you get 5 out of 9. So we can conclude and say that our variance will be 513 out of 9, which you can simplify. Which you can simplify. Which you can simplify. So, my dear candidates, allow me to give you one number that you could try out as we finalize. Allow me to give you one number that you could try out. As we summarize, try out this. A random variable x with a function f of x with a function f of x is 0 x squared over 16 ax minus b 1, and we have 1 out of 16 into 12x minus x squared minus 20. We have x less than 0. We have 0 less than x less than 2. We have 2 less than x less than 4. And we have x less than x less than 6, and x greater or equal to 6. This is a cumulative distribution function, and you are asked to find number 1, values of a and b. Number 2, find the median. Number 3, find the 4th decile. Number 4, find the 90th percentile. And then find the semi-interquartile range. You can take a picture of that question so that you are able to try it out in your free time. I want to, of course, thank you for being good students. Urge you to continue working through. This is a very popular topic. And continue visiting my YouTube channel, Teacher Kakuru, and continue asking where there is need. I want to wish you the best. God bless you. Have a nice evening.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero lya bawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory, ssaako ne computer lab wamu ne
Kids Kingdom Kindergarten and Daycare.